Well, first of all, welcome everybody to All About Dependencies. This is the Maven Puzzlers. Andres and I love dependencies and we love tools. So welcome everybody here. And this is our first time in Israel. And so far we have been enjoying it a lot. Yes.
Thank you so much.
I'm actually ecstatic. And this is a little bit about the map about myself. I'm from Mexico. I live in Switzerland. I'm a Java champion. I work for JFrog. I collaborate in a lot of foundations of open source. So open source is my life. I also collaborated in some books. The most recent one was DevOps Tools for Java Developers. So that's me.
So, and myself, I'm Andres Almiray. I'm also Mexican living in Switzerland. I love open source. I like to talk about open source technologies and build my own tools. One of those is JavaLeaser, for which I have stickers, that one over there. Another project I created is called Griffin for desktop applications. And today, the idea is to showcase some of the lessons that we have learned across the years by using build tools.
And it's not that I'm braving anybody here, but we have Swiss chocolate.
Yeah, we mentioned that we're coming from Switzerland. There's Swiss chocolate right there. So if you ask questions, then you get some chocolate.
And this is going to be the first session where the speakers are going to ask you to get your phones out. And I will explain a little bit why. So I'm a software developer. He's a software developer. And software, it's our world. It's the place where we find ourselves more free, the thing that we do in our spare time, and what keeps us going. We love open source and we love source. And we also loved sharing knowledge. And this is my personal motto. I mean, whenever they ask me, Ixchel, what do you do? I'm a human writing code for humans to improve human lives. Because even if we write code, we spend more time reading code from somebody else. And that somebody else is even us 6 months from now. So be kind when writing code. And the whole reason of writing code for me is to improve human life. So human is at the center of my life as a developer. And one of the things that we love to do is to improve developer happiness. And how do we improve developer happiness? Is by knowing and using tools that improve your productivity and reduce stress. So Andres was mentioning JavaLeaser, which also follows the same principles. We like tools that follow conventions that are reliable, automatic, predictable. And today we're going to talk about one specific tool that we all use, even if we don't know about it. For example, in the Java world, 70% or more than 68, this is according to the JRebel Java Developer Productivity Report of 2022. So 68% of projects out there are built with Maven.
So in this case, they're using Maven as the main build tool. And there are many other build tools that you can use in the VM, in the Java virtual machine. But Maven happens to be the most popular one, or the one that most people use. And I'm not saying that people like to use it. It's just that it's very common.
And this is another report for JBrains. This is the developer ecosystem of 2021, according to Java. And again, Maven, it's 72%. Even if you are using Gradle as your build tool, you're still consuming Maven or Pumps. Who here uses, for example, a Spring Boot? A lot of hands, my kind of people. Or Quarkus.
Not that many. All right.
So these tools will have something that we will explain in the few minutes. Why we say that we are still consuming home files. So today the focus was on Maven.
By the way, you see those QR codes appearing on the slides? That is the quick link to the different URLs that will show through the presentation. So you're free just to scan those codes and go directly to the resources.
So let's talk about jars, Andres.
Yeah, but not those jars.
Okay, let's talk then about dependencies. And there's something interesting about dependency. Dependencies are not always the same, and we use it in different moments of our software development cycle. And this morning, there was a very similar, well, not similar, but interesting session about the dependency hill. And we totally felt identified with the developer, because for us, the dependency resolution can also be problematic.
Who has felt like that when building their project at some point, right? I will have expected most of you to raise your hand. If you didn't have enough coffee this morning? Come on.
So, before I run into that one, what's the first thing you do when you join a project?
Well, first, before we get into that, let's see some hands again. Who uses Maven as the primary or the major build tool? See? It's close to 70%.
Well, they are in the Maven Postler session.
Who uses Gradle? A few hands. SVT? Line again? No one from Clojure. Okay, so here's a real tough question. Who still uses AND? Wow. Good. Legacy, that keeps working.
Okay, so the question that I wanted to ask is, what do you do when you join a new project? Like, you check out the project, and what do you do? What command the first command that you run?
What do you use to build the project?
Who does Maven clean install? Okay.
The door is over there. Please get out.
No, it's because if you haven't followed Andres, he has very entertaining rants about why you shouldn't use Maven clean install. But I'm not going to talk about all the reasons why you shouldn't be using it. I will only say that sometimes, for a very specific use case, it is really good to use Maven clean install. But for most of them, Maven verify will do what you want.
Who uses Maven verify already? Okay, so I hope that by the end of the session, everybody should be using Maven verify. And here goes a very, very tiny rant of why Maven verify is better than clean install. This is the standard Maven life cycles. There are many, but most people use this one. You see, for the case of clean, it just goes from start to end. The life cycle is a linear execution of phases. And for each one of those phases, plugins will execute their behavior. The mojos are bound to phases. So in the case of the standard lifecycle phase, whenever you say compile, package, test, install, you go through that on the top. And notice, when you go through all of this, there's compile, test, package, deploy, install. What is the phase before install? Verify. Every time you invoke install, verify is actually run. So you always see it there, right? So don't be afraid by saying, oh, I'm going to run verify, something that I've never seen before. Well, you have not seen it before explicitly, but it was run there before earlier. Verify, make sure that you compile, test, package, run integration test cases, and you're done. The install phase, which comes right after, the only thing that it does is publish the built artifacts, the jars and the POM files, into your Maven local repository. That's the only thing that it should be doing. Now, why do we do clean install all the time in a multi-project build? Because one project may depend on another. We need those artifacts to build. Well, guess what? Those artifacts are part of the whole multi-project build. It's called the reactor. You don't need to do clean install all the time. Verify will make it work. There are cases, though, where you need to resolve an artifact from a repository. There are some special test cases. In this case, it's likely you have to do clean install. If you avoid clean install, then you also avoid the problem of stale snapshot dependencies in a repository, which I'm pretty sure some of you have been bitten by this problem that you run in a test case, things are not working, 3 hours later it's like, crap. I pushed the wrong dependency into my artifact, into my repository, and now I refresh that and everything works. That's the reason, that's the problem of using cleanst all the time. So let's close this rant because I could go hours about this. We have other things to look.
Okay, so the actual thing that we want to talk about is dependencies and the resolution and the tree that we're going to see. So when we are developing new software, and actually 70% of the code base out there uses open source, and most of that open source also has dependencies in itself. So when we start adding dependencies to our projects, chances are that we're going to introduce the same dependency, but probably with different versions as transitive dependencies. So the problem starts like when we realize that we don't understand quite well what is the actual dependency that we are going to load into our class loader. So, for example, when we have the same dependency but with different versions, then levels, hoops, steps actually start being important.
Okay, so now we're going to turn into the interactive part of the session. So all of you that have a phone with you, please take it out, scan the following QR code, and log into, and we're going to ask a series of questions. Now, if for whatever reason you were not able to scan that QR code, the URL will still be pointed at the top, and there is a code that you can use to participate.
Yeah. Oh, thank you for the hearts. Okay, so let's start.
Okay, so we're going to do a very series of basic questions, and then we get into the proper quiz. So how do you install Maven today? There are, of course, many choices. We just decided to put 4 of them. Wow, that's interesting.
Yes. So for those that doesn't know SDK Man, I totally encourage you to start using SDK Man, or at least have a look at SDK Man.
Because for those of you who have chosen Homebrew, that's pretty well, that's nice, because you know that when you use a package manager, this thing knows where to download the code, in this case, the distribution, configure environmental variables, and off you go. The problem with Homebrew is that when you need to use a different version of Maven, you also use Homebrew to install it, but then you can only have one single version of Maven. Whereas SDK Man allows you to have multiple versions of Maven installed at the same time, and you can switch between one and another. So it's easier.
Between terminals. And SDK Man also works for Java and other dependencies. So think about us. You have one version of Maven in one of your terminal windows and a different version of Maven in a different window, terminal window. And that also happens with Java. You can have one version of Java with one distribution in one terminal window, and in another terminal window, in another tab, you have a different version of Java. You can start moving around without changing your Java home environment variable, without doing the download and installing and uninstalling. So have a look in the SDK Man. What version of Maven do you use?
Okay, let's see how upgraded we are.
Okay.
All right.
So what version should we avoid, Andres?
So you notice that there is a gap between 3.8.4 and 3.8.6. There is a version 3.8.5, but do not use it. It has a vulnerability with dealing with remote resources and HTTPS. So that's why we're not listing it. Either, I hope that you have upgraded to 3.8.6. It's not even 50% of you. And 3.8.4 still has that vulnerability. And of course, 3.6.3, which is way old. I see some people, 17 people that are using a much older version of Maven. I urge you to upgrade as soon as possible.
Okay, do you use the Maven wrapper?
Do you know what the Maven wrapper is? Yes? No? Okay. Maybe? So the Maven wrapper is a script that allows you to run Maven. But if the system where you want to run Maven does not have that particular version or no Maven at all, then you cannot run the build, right? The wrapper has certain capabilities to download Maven for you and run the build. So with this, you can say, my project builds with Maven 3.8.6, and I ship it to my teammates, and then my teammates will use the same version 3.8.6, and even more, I can now build on CI using that same version of Maven, even if I start from scratch for an empty environment and Maven was not pre-installed. That's the advantage of using the wrapper.
And let me tell you that the versions does matter, because some versions will have a specific super poem and some definitions of the basic plugins. So disregarding the version, the Maven version, is not very advisable. So do you use the Maven daemon?
Last one. Do you know what the Maven daemon is? So just like any other Java-based tool, command line or not, what do we do when we launch the tool? We boot up a JVM, run the tool, and once we're done, what do we do with the JVM?
Kill it.
We kill it. The next time we run the tool, what happens? JVM goes up, run the tool, goes down. Now, bootstrapping the VM is an expensive operation in terms of time. What if we're able to reuse that VM? That's exactly what the daemon does. The first time you run it, of course you have to bootstrap the VM, run the tool, and then this VM goes into a background process. So by the next time we do a next build, we don't pay the price of bootstrapping the VM. We use the one that is already running. So the next build and the next and the next is faster. This means that if you are experiencing slow Maven builds, besides using profiles and using the wrapper and other techniques, have a look at the Maven daemon.
Okay, those were the warm-up questions. Let's start with the real questions. So when we said that this is working, or what this is going to be the version that we're going to define as correct, it's because we are running the Maven dependency tree command.
So every single question is like, imagine yourself running Maven dependency tree. What will be the output?
Yes. So let's start. If I have this POM, see, it's a very simple POM. We have the dependency block. We define a direct dependency, Google Guava version 27 and Google Guava 28. What is going to happen here?
So first off, we're not going to dunk on Guava just because it's Guava and everybody hates Guava, but it's so pervasive that it's very likely that you're going to find a trouble like this. Now, what we're going to showcase here will work or won't work for all kind of dependencies. It's not just Guava.
Okay, so my first question when I read this, and I told Andres, I'm defining the same dependency in the same file, one after the other, and there are two different versions.
Okay.
Is this not a problem?
So when we attend dependency resolution, what happens? Let's see. 41% of you, 42 now, 44. Oh, so who gives more? This should be a build error. This is clearly it's a problem. Yes. Is it a build error? No, it's not. It's a warning. Maven will output a warning saying, hold on a second, this POM file looks weird, but I will allow it. And by the way, if you go back, the chosen version, remember when we saw in the XML, version 27 was first and version 28 was second?
Okay, he wants to go back to this one. Okay, perfect.
The chosen version was 28. And then maybe you may be thinking, of course it's 28. 28 is bigger than 27. Well, that's not the reason why 28 was chosen. It was chosen because it was the last one defined in the XML.
So let me be very clear. Semantic versioning is something that we should be using as developers. That is super useful. If you are not using semantic versioning, I urge you to have a look into the definition of semantic versioning.
But Maven does not use semantic versioning at all. It doesn't care about that.
Doesn't understand that. So for those that said, Ixchel, it's super confusing that you're defining two different versions of the same dependency in your POM file, and that is not a problem, I'm with you. So how do we make it to be a problem?
If there is only one thing that you take away from this session, is please have a look at the Enforcer plugin, configuring your build, and guarantee it's going to break it. And that's exactly what you want. You want your builds to break as soon as possible, find out any potential problems that you have, and fix them. What the Enforcer plugin does is you have options to many different rules, and the one that we're going to configure in this case is one that says ban duplicate POM dependency versions. So when you put the following configuration or similar configuration in your POM file, register the Enforcer plugin, you can bind it to many phases if you want to. The important bit is define this rule. And when this is active and when you enforce your POM file, then you get the following error appearing on your console. It says we have more than one time explicit version to a dependency, in this case, Guava, obviously.
So, that is not a problem. You can define as many direct dependencies as you want, and that won't be an issue. So let's continue. Second example. We have, again, our POM. We have a direct dependency on Guava version 28, and we are also adding Google Truth. Truth has as a transient dependency Guava 2.
Okay, so that means an explicit version of Guava and a transitive version of Guava somewhere in the graph. So when we resolve dependencies, what's going on? Are we going to get the version coming from the explicit one, 28? Are we going to get the one coming from the transitive, which I think is something like 31 GRE? Android, yes. Or is somehow this will be a build error?
Okay, so most of you actually answer version 28.
And that is the correct answer, because explicit versions will always win over the transitive ones. Because in the graph, when you see that Maven is computing the graph, it says everything that is defined here in my POM, and the next thing is all the direct dependencies, so Guava and Truth, and then Truth has, going into the next level, Guava and so many others. So Guava on the first level, Guava on the second, this one wins because it's closest and it's explicit.
So let's go back to the slides again. We already said this. Maven doesn't care about semantic versioning. So we asked this particular question over Twitter. And at that time, and look at the dates, 26th of March, 2020.
Of 2020. It's 2 years and a half ago.
Yes, and Robert showed that it was the PMC of Maven at that time. He actually said this. Maven never looks to the version, but always to the location in the tree. So don't think that it's going to pick the newest version defined in a POM file. It's actually going to use the last defined in the order in your file.
When it's explicit.
When it's explicit. Unless you are using that specific Maven enforcer rule, and then it will actually force you to only define one specific version in your POM, in your effective POM.
So we can fix this again by using the enforcer. There are two rules we may use. One is called dependency conversions, and this one says anywhere in the graph, if you have more than one definition of the same dependency, group ID, artifact ID, but if there are different numbers, it doesn't care what number it is, but if they are different, then it will raise an error.
He won't tell you, please use the latest or please use the oldest, because he doesn't understand what latest and oldest mean.
So when we configure that, look at, we get a problem with Guava, but we also get problems with other transitive dependencies that we didn't see before. Now, depending on your use case, that may be a problem. The other one that we can use is called require upper bound depths. Now, this one is the one that kind of tells Maven to use or understand semantic versioning. Because it not only says, oh, you have two different versions of Guava here, but one of them is bigger than the other. So go and select the bigger one. So now we get this. When we say manage, this is the one that is explicitly defined in the POM file. But in the transitive graph, we got this version, 31.1 Android. So the require open bound dev said, pick the latest one.
Next question. So now, look, we have the dependency management block.
We have used the dependency management block before.
Okay, good. So we have the dependency management block, and there we have Guava version 27. And in the dependency, we specify truth with version 113. And truth, remember, is bringing Android
31.1 Android. Okay, so which version is going to be the chosen one? We still have some people choosing build error. Interesting. Well, let me tell you, this POM file actually works. There's no build error here. And version 31.1 Android is the biggest one, is the latest in this case. But so happens that the chosen version will be the one defined in the dependency management block. Now, the dependency management block works like if it were like a lookup table. Anywhere in the graph, if there is a match for that group ID and that artifact ID defined in the dependency management block, then the chosen version will be 27. Because Guava is brought here as a transitive, the chosen version will be 27. If we were to define an explicit dependency here without a version number, if we were to say Google Guava here without version number, the chosen version will be still 27.
So, the only way for this to win is if you actually say version. If not, dependency management resolves this for you.
Okay, so next question.
Next question.
We have the dependency management block. We have an explicit dependency to Guava, and we know we have a transitive dependency coming here as well. So now we have version 27.
28 defined here as a direct, and 30 here as a transient.
So who's going to win?
Yes! 27, 28, or 30.
It's a bit of a split. Okay, good. So I'm happy that you have not chosen 31.1 Android. That would be definitely wrong. But now it's a toss between 28 or 27. Well, the correct answer is 28 because it's direct and because it's explicit. If I did not have added this version number here, 27 will win.
So, direct dependencies with version will win.
All right, next one.
Okay, so first a little bit of information. So, for example, this is the dependency tree for, which one is this one? Google Truth version 113, that introduces Guava 31, and the other one introduced Juice with Guava 30.
So we have two different versions of Guava, but they are at the same distance. That is important.
Both are transient.
So now we have a POM like those, looks like this. Juice and Truth, we know there are two versions of Guava coming here as transitives. Which is going to win? Is it going to be the version coming from Juice, which is 31 GRE, or is it going to be version 31.1 Android coming from Truth?
So what do you think is going to happen? Which transient dependency will win in this puzzle?
I am very, very happy to see that 9 of you have chosen the right answer. Yes. What's going on? Hold on a second. The first question, remember, we got version 27 and 28 and 28.1 because it was the last one defined in the XML, right?
Yes.
So obviously, for transitive dependencies, it should be the same. So no matter what I have here, the transitive coming from the last one should win. Yes?
No.
No. Why is not the case? Because for transitives, the position in the graph is important. And it was the first one found at that same level. Recall that the two Guava transitives are at the same distance from the POM file. So when Maven was resolving dependencies, it found juice first because it's defined first in the XML, and finds Guava for that one first. So I grab it.
False love.
And then parses this one and says, oh, I find another Guava, but guess what? It's at the same position, same level as before, so I toss it away and I use the first one.
So transient dependencies is the other way around than direct dependencies. Keep that in mind.
Okay, last one. So what we did here? We only added a dependency management block. Again, we have two transitives. So we have three probable versions of Guava coming up. 28 from dependency management, or 30 GRE, or 31 on Android.
So we only added the dependency management. What happens now? Which is the final version? And thank you very much.
You're paying attention.
You're paying attention. This actually fills us with joy because yes, it is going to be the one in the dependency management because it's going to be using it as a catalog. This doesn't define a version, so the only version that is going to be using is the one that is there. Right. It doesn't matter what are the versions on the transit dependencies ones.
So how are we doing so far? Because so far we have only dealt with a single POM file. Things are easy with just one project. What happens when we add more projects into the mix? What happens if we add parent POMs? And now remember that most of you said you're using Maven, so this makes a lot of sense where you're using Maven POM files and parent POM files. But if you happen to use Gradle, you don't consume parent POM files as is. You just consume the leaves of all the dependencies. So you don't care about parent POM files. Yet, the way that dependency resolution works and the way that the things are specified in the POM file format are important for you to know, even if you're not using Maven as a build tool.
So what we're having here is a parent POM, and in the parent POM, you can see that we're defining in the dependencies Guava version 28, and in the child POM, we have only a dependency, a direct dependency on truth.
Which we know is going to bring Guava as a transitive.
Yes.
So which one is going to be the chosen version? Is it going to be version Guava from the parent, or is it going to be the transitive from the child?
Okay. So we have some answers, but why don't you explain what is going to happen, Andres?
Okay, so what happens when Maven reads these two POM files is the following. It starts with a child and looks at its gap coordinates, so group ID, artifact ID, says, oh, you have a parent. All right, so I'm going to stop here and then locate the parent and then parse the parent. And then what does that find in the parent? The gap coordinates, obviously, and a dependency. Okay? Because it doesn't have a parent, it will still try to go to the next level, which is the Maven super POM that defines the basic bindings for the compiler plugin, the clean plugin, all those things that we get for free. The super POM defines no dependencies, so it stops. Now it goes back into the parent, finds the dependency, grabs that and puts it into the effective POM, then goes into the child and reads into the dependencies and looks like it has a dependency on truth and puts that into the effective POM. So picture in your mind, effective POM looks like this. Gap coordinates, explicit Guava, and Guava as a transitive. Who's going to win? We have seen this use case before. Explicit is going to win. And this is the case why version 28 is the chosen one.
Yes. Okay. Next example. What we have done here is added a dependency management block on the parent POM.
Right. So that's the
Nothing
only change.
has changed.
The only change is there, the dependency management block.
So what is going to happen? We added a dependency management block on the parent.
So we have three choices, 26, 28, and 30.
Okay.
Build error. Interesting.
Okay. So, what is the correct answer?
Let's show the answers.
Oh, I already showed the answers.
So the correct answer is 28 because it's an explicit dependency, it's a direct dependency. And again, if we look at the order of how the POM files are parsed, we have a dependency management block in effective, we have a direct one and a transitive, so obviously the direct one wins. Good.
Oh.
You're paying attention.
So in the last 5 minutes, we have now a different case. We added only, what did we add?
We have only a dependency management block in the parent and a transitive in the child. So when we resolve dependencies, who's going to win? Is it going to be version 26 from the parent, or is it going to be 30 from the child?
So a lot of people say that it's going to be 26 because this is coming from the parent.
Yep, and that is correct.
Thank you very much for that.
All right, so final thing is dependency management on the parent, dependency management on the child, and a transitive dependency. Who's going to win? Version 26 from the parent, version 28 from the child, or 30? Let's see.
So, who has the last say? 28 the child or 26 the parent? Who knows best?
At this point, you should not have chosen version 30, 1100.
Yeah, no, that's for sure. So the last word is from the child perspective.
Because when you look again into the order of parsing, when we look into the parent, when going back, we have a dependency management block here. And we got into the child, we have another dependency management block that matches the same coordinates. The child overrides whatever is coming from the parent. That's why the version 28 from the child wins.
Okay, and finally, we're introducing a new concept, which is the BOM files.
Who knows what a BOM file is? A bill of materials. Who uses a Spring Boot? JUnit, Jackson. You've been using BOM files, even if you have not used it explicitly. So a BOM file is just like any other POM file that defines a dependency management block. That is the most important bit about a BOM file. So dependency management.
The BOM dependency management. They are like parent POMs, but not really. So this is the key part.
The key part is that. So here we have a BOM file that defines, it can define multiple dependencies. We're just keeping it simple with being just Guava. Right? So we have the BOM file. And notice on the other side, we consume the BOM file. And we consume it in this way. We use our dependency management block in the consumer. And we have to add 2 additional settings. Scope import and type POM. If we don't do that, then maybe we'll try to resolve a jar file that does not exist. Because notice again, in the BOM file, the packaging is of type POM. So when we resolve dependencies, who's going to win? Is it going to be the version provided by the BOM? Or is it going to be any of the transitive dependencies that we got here?
Well, thank you very much for that. Yes, you are correct. It's going to be version 28 because the dependency management is going to be like copy in pencil. And you will see why I mentioned copying in pencil into the child or in the effective POM of this particular
Basically, when we say we're importing a BOM file, it is as if we grab the dependency management block from the BOM and we copied it over into whoever is doing the importing. So that dependency management block will be here. And we have seen this use case before.
Well, not this particular one. We are on the next one.
Okay. So in this case now, we have a dependency management block here. We have an explicit dependency on the BOM file. And we consume that here, so we have potentially 3 versions of Guava, 26, 28, and 30. Which is going to win?
Dependency management on the BOM, it's 26. The direct dependency on the BOM is 28. And transient dependency on 30. So, people say 28.
28 because it's here, right?
I told you guys... In the BOM, it only matters the dependency management block. Okay. The dependency doesn't matter.
When we import a BOM file, this block is the only one that matters. Everything else is completely hidden. So even though we have an explicit here, it's invisible to the consumer. That means the chosen version should be 26.
Yes.
All right, so we have 2 more questions to go, and we're done.
Yes. Let's go fast. So now, again, in the BOM, we have dependency management. On the on the other project.
On the child, we import that BOM. We define another explicit dependency here on Guava, and we know there's something coming transitive here. So we have our choices. It will be version 28 from the BOM, 26 from our dependency management block, or 30 because it's transitive.
So actually, the real question is 28 or 26. Who is going to win?
Please, no build error.
No build error, for sure.
Oh, there's a build error.
Okay, I am happy to report that it's 26.
The chosen version will be 26. Why? Because explicit dependency will always win over, and dependency management block, regardless if you say it explicitly like that or import a BOM, does not override explicit dependencies. So this one wins, no matter what. If we put this before or after the import, this will continue to win. So last question.
Last question. So we have in the dependency management version 26, we have as direct dependency 28 and a transient dependency.
Yep.
Sorry? Yeah.
So who's going to win?
Yes, you're right. It's going to be the direct dependency because the direct dependency always.
And this showcases that no matter what we say in the BOM, no matter how many times we import it and in which order, a direct dependency will always win over.
So all these examples are in that GitHub repository. So you want to check the different branches. We have the questions, we have the answers, and you can run them over there. And I hope you get this idea from our session. Use the Maven Enforcer plugin. It will break your build for sure, but that's what we want. Second of all, transient and direct dependency work not consistent.
Well, it's consistent if you know the rules. But
yes, semantic versioning doesn't mean anything for Maven or the other way around.
So the important bit is that for all of you that do not use Maven and stay for the end of the session, thank you so much for keeping up with us. Because even if you don't use Maven, you will consume POM files that are built in this way to solve problems in Maven. But that they might cause trouble to you. Because if the type of application or the project I'm building, if I'm building an application that I can solve all my dependency problems or most of them using dependency management block. But if I'm building a library and I've used dependency management block, that only solves my build problems, but it does not solve whoever consumes my library. If I want to fix one version for my build and I want everyone else to use that dependency, I have to make it an explicit one. If I fix just using dependency management block and BOMs, I'm still pushing trouble to someone else. If you don't want to rewrite your POM files to do explicit dependencies wherever it's needed, then I also recommend you to have a look at another plugin called the Maven Flatten plugin, which can rewrite your POM files to, once all dependencies have been resolved, then use the specific versions into the actual POM file that's going to be published. So your consumers, be it Maven, Gradle, SVT, or whatever it is, will have the right dependencies.
So thank you very much, and I hope you learn a little bit about Maven and its rules.